This is the Nezha Inventor Kit from Elecfreaks designed for the Microbit. The packaging is seriously impressive. I mean, shout out to Elecfreaks for putting so much thought into the design. This box already looks awesome on the outside. I can't wait to see what's inside. Everything is so neatly packed. Honestly, this is one of the most well-organized kits I have seen in a while. I mean, just look at how different components have its own little compartments. I can already see the wheels, the ultrasonic sensor, and some RJ11 cables. And I have no idea what this thing is. I have never seen anything like it before. Let's just put it down for now. This one looks like a soil moisture sensor. Look at that. There is a little drop of water and some leaves printed on it. I don't know if you guys can see that clearly, but yeah, this is definitely a soil moisture sensor. Some input and output modules. This one is the NISA expansion board, and I think these are motors, and this one looks like a servo. Each component comes in its own individual plastic pouch. It's not fully transparent, but you can still kind of see what's inside. They are properly sealed. That really gives a premium feel, and it shows that Elecfreaks put some real thought into the presentation. Under the tray, boom, there it is. The brain of the whole kit, the Microbit. Oh my god, over 400 plus building bricks. These bricks allow kids to bring their ideas to life. Whether they imagine a robot, a car, a crane, or a machine, they can build it piece by piece. This helps kids use their imagination and understand how real machine works in real life. To help kids get started, Elecfreaks has created over 70 fun and educational projects with simple step-by-step instructions. These projects teach children how to connect the building bricks and build exciting things. If you're new to Microbit and feeling confused about where to start, don't worry. I have already made a full, easy to understand video where I explain everything about Microbit in detail. In that video, I guide you step by step through the basics, how to do programming, and even show real examples by running code on the CubeBot. It's not just theory, I show everything practically so you can follow along and learn by doing. So, if you or your kids don't know anything about Microbit yet, I highly recommend watching my CubeBot video first. It will give you a strong start and make learning fun and easy. Let's first start with the NISA expansion board. This board helps you connect all kinds of sensors and motors to your Microbit. At the top, there is a place to plug in your Microbit. Right next to it is the power switch and a tiny LED to show the power is on. It even has a USB charging port so you can charge it up easily. These red boxes here, labeled 1, 2, 3, 4 are sensor ports. These are I2C ports. At the bottom, you can see M1, M2, M3 and M4 ports. These are for motors. If you are building a robot or a car, this is where you plug in the motors. These 4 ports labeled S1, S2, S3 and S4 are for connecting servos. Make sure to download this pinout diagram. And guess what? The best part is that the NISA expansion board comes with a built-in rechargeable 900 mAh lithium battery. That means your kids don't need to keep replacing batteries again and again. Just charge it once and they can enjoy up to 2 hours of non-stop building, learning and playing. Before using it, make sure to charge it. All these examples are for intermediate level users who already know about Microbit and how to use basic sensors, motors, servos, and other modules. If you look at the first example, even someone with experience might take a lot of time to make it. You should not give kids a complicated project right away. First, teach them how to use each module one by one. Once they learn how to use sensors, motors, and servos, their mind will start to open up. And then they will be able to build even the most complex projects easily. So let's first start with something simple, the LED modules. For this example, we need the red, yellow, and green LEDs. The NISA expansion board with the Microbit plugged in, a USB cable to charge the battery, and upload code to Microbit, and RJ11 cables to connect the LED modules to the NISA expansion board. You don't have to connect the building blocks exactly the same way I'm doing it. Feel free to use your own creativity. There is no right or wrong way. Just use your imagination and have fun with it. RJ11 cables have made interfacing so easy, I don't even need to worry about the polarity. We have finished the wiring, so now let's write a program to control all the three LEDs. Go to the makecode.microbit.org and simply log in with your Gmail ID. Click New Project. Give your project a name. You will see an interface like this on your screen. I have already explained all of this in my previous video on the Qt bot. To use the NISA kit, the first thing we need to do is add some extensions because the blocks we need aren't available by default. So to access those blocks, let's click on Extensions. Search for NISA and click on it to add it to the toolbox. Once it's added, if you click on NISA, you will see blocks for controlling motors and servos. We also need sensor blocks, so let's click on Extensions again and this time search for Planet X. Click on it and add it to the toolbox. If I click on Sensor, you will see blocks for digital, analog, and I2C type sensors. If I click on the input, you will see input blocks for digital, analog, and I2C type sensors. Similarly, if I click on Execute, you will see execute blocks for the digital and MP3. If I click on Display, you will see the LED block. That's the one we need for this example. We will use this block to turn the LED on and off. You will also find blocks for OLED display, 8x16 matrix, and 7-segment display. Feel free to also explore the NeoPixel and Planet X IoT blocks. Anyway, that's all the extensions we need for now. The onStart event is similar to the white function in the Arduino programming. So, onStart is an event that runs when the program starts. Use this event to initialize your program. Similarly, forever event is similar to the loop function in the Arduino programming. So, if you want to run a part of your program continuously, you can place it in the forever loop or event. Before starting programming, connect Microbit to your PC or laptop using a micro USB port. Now, let's go to the Planet X display and use the LED block to control all the three LEDs. To upload the program, simply click on the three dots and then click on Connect Device. Click on the Next button. To pair your Microbit to your browser, click on the Pair button. Finally, go ahead and click on the Download button. You can see all the three LEDs are turning on and off every second. Next, we are going to control the on-off time of the LEDs, and for that we will use this potentiometer or temp pot. As you know, a potentiometer is an analog sensor, and the NISA expansion board has two slots for analog sensors labeled 1 and 2. So let's connect the potentiometer to slot 1 and connect the LEDs to slot 2, 3, and 4. We are going to modify the same code. Go to Planet X base and then click on the input. Under analog, you can see trim part. As you can see, I can now control the delay time as I want. In the next example, we are going to control the LEDs using a crash sensor, which is basically a limit switch. It works just like a push button. The only difference is in its design. Let's start a new project. Whenever you start a new project, you'll need to add the required extensions again. After that, go to the Planet X display category and add the LED blocks. The LED modules are connected to ports J2, J3 and J4. This time, we'll use an if-else condition to check whether the button on the crash sensor is pressed or not. If it's pressed, all three LEDs will turn on. If not, all the LEDs will stay off. To do this, go to the logic category and drag the if-else block into the forever loop. Then, go to the Planet X base category, click on Input, and drag the condition block to place it where it says true. As you can see, all the LEDs are off. That's because I haven't pressed the crash sensor yet. Watch this. When I press the button on the crash sensor, all three LEDs turn on instantly. And as soon as I release it, they go off again. This is happening because I have used an if-else condition in the code to check the state of the button. So basically, it's just like using a regular push button. Next, we are going to use a line tracking sensor. It basically has an infrared emitter and receiver built in. When it's placed over a white surface, the IR light reflects back and the sensor detects it. But when it's over a black surface, there is little or no reflection and the sensor picks that up too. So I'm going to use that behavior in a very simple way. When the sensor detects black, I will turn on the red LED. When it detects white, I will turn on the green LED instead. Now, this might look basic to you, but once you get the hang of how this sensor behaves, you can take it way further, like controlling motors, servos, and even building a line following robot. I have started a new project. Now, by this point, you already know exactly where to find the LED block. We are going to need two of them, one for the red LED and one for the green LED. The red LED is connected to J2 and the green LED is connected to J4. Next, I will head over to the logic category and grab an if condition block. Then I will go to the Planet X base category, click on sensor, and look for the block that's specifically for the line tracking sensor. Let's drag that in and place it right where it says true in the if condition. Now, we are ready to start building the logic based on whether the sensor detects black or white. Next up, we are going to use this soil moisture sensor. Since it's an analog sensor, I will connect it to port 1 on the NISA expansion board. Now, here's the logic I want to build. When there is no water, the red LED should turn on. When moisture is detected, the green LED should turn on. And for the practical demonstration, I'm going to dip the sensor into this glass of water. By now, I'm sure you guys have a pretty good idea of how to work with LEDs and if conditions. Now, we are going to take it a step further by using comparisons inside the if condition. So here's what we will do. If the soil moisture is greater than or equal to 40, then the green LED will turn on. But if the value is less than 40, the red LED will turn on. Simple logic, right? Alright, let's do it and see it in action. Right now, the red LED is on because the soil moisture sensor is out of the water. Now watch. As soon as I dip it into the water, the green LED turns on. Great. That means the soil moisture sensor is working and we are able to control the LEDs based on the readings. But here's the thing. We still don't know the actual moisture value. So let's take it one step further and print the moisture value on the LED matrix. That way, we can visually monitor the soil moisture value. To print value on the LED matrix, go to the basic category and use the show string block to print whatever you want to display on the LED matrix. Now, not only can we control the LEDs based on the soil moisture sensor readings, but we can also see the exact value displayed on the LED matrix. But this demonstration, I'm simply using a glass of water instead of soil just to show how the sensor reacts. When the sensor is out of water, the moisture level drops. The value on the matrix is low and the red LED turns on. As soon as I dip the sensor into the water, the value increases and the green LED turns on. So even without soil, we are able to test and understand exactly how the sensor behaves. This makes it much easier to experiment and build confidence before using it in a real project. Next up, we are going to use the servo. Servos are really useful when you want precise movement, like opening and closing a door, turning a dial, or even moving a robotic arm. We will connect this servo to the NISA expansion board and control its angle through code. Once it's connected properly, we'll write a simple program to rotate it to different positions, say 0, 90, and 180 degrees, just to see how it behaves. It's going to be a fun and hands-on way to understand how servos work and how we can use them in our own creative projects. Next up, we are going to use this ultrasonic sensor to control the servo. We will use the distance readings from this sensor to decide how the servo moves. For example, if something comes closer than a certain distance, the servo can rotate to a new position like triggering a gate to open or a barrier to lift. Let's modify this code. Next up, we are going to use these motors. We will control their movements forward, backward, left and right. Once you understand how to control these motors, you will be ready to create line following robots, obstacle avoiders and much more. You can download all the examples we covered today, plus extra resources from my Patreon page. We have got some exciting intermediate and advanced projects coming up in the next videos, so stay tuned. That's all for now. Support me on Patreon for more videos. I hope you liked today's episode. Like and share this video with your friends. See you in the next episode, and thanks for watching.